Hi, teacher Argentina. My name is Sebastián Leiva, and with my partners Jessica Rojas, Diego Arbizu, and Javier Anaya, we will present our partial project. Here, here are the evidence of our photos with the candies. And this is the information we collect each one. This we have the total amount of candies that are 124, and the C1 that was 51, and the C2 that was 73. And we will resolve these following problems. And the first one say if a candy is randomly removed from the package, what is the probability that is C1? We only have to do a little division. We divide 71 between 124, and they give us the answer that is 41%. And the second problem is says if a candy is randomly removed from the package, what is the probability that is not C1? And it's almost the same as the last problem, but we will change the 51 for a 73, and we will have the result that is 58%.
Okay, the third problem says if a candy is randomly removed from the package, what is the probability that it is C1 or C2? So we did a sum here. We sum 73 plus 51 over 124, and then that gives us 100%, or this division. The fourth problem says if you randomly take a piece of candy out of a package and eat it, what is the probability that when taking a second piece of candy, it is C1 since the one you ate was C2? So we do a multiplication. We multiply 73 over 124 for 51 over 123. And that gave us this number, which is simplified in 0.24 or 24%. The fifth problem says if you randomly take a candy out of the package and return it, what is the probability that when you take out of the second candy, it is C1 since the one you returned was C2? So we did the same that we did the last problem. We multiplicate 73 over 124 for 51 over 124, and that gave us 0.24 or 24%, which is the same than the last problem.
In the problem number 6, we need to if we have two candies, no, if two candies are drawn at random, one followed by the other and without return the first, what is the probability that the first is C1 and the second is C1? Here we need to divide 51 out of 124, and we need to multiply with 50 over 123. It equals 425 out of 2,542. That is equals 0.16, and the final answer is 16%. In the number 7, if two candies are drawn at random, one followed by the other, and without return the first, what is the probability that the first is C2 and the second is C2? This is the same as the other one, but we are taking the C2. Here we need to divide 73 over 124 and multiply 72 over 122. That it equals 438 over 1,221. That it equals 0.34. The final answer is 34%. In the number 8, if two candies are drawn at random, one followed by the other without returning the first, what is the probability that the first is C1 and the second is C2? It's the same as the other two problems, but we need to have one C1 and one C2. We need to divide 51 over 124, multiply 73 over 123. That it equals 1,241 over 5,053. That it equals 0.24, and the final answer is 24%.
Here is our tree diagram of 6,000, 1,000, 2,000, 3,000, 4,000, 5,000, and 6,000. So for the table, variable distribution, to calculate the values and make this table, we had to make a tree diagram based on the first 2,000. We had the first branches of the two launches along with its branches in case you don't grab any suite C2, that is the color white. We use the chance of the probability of 51 out of 124. And as for the second shot, which is what tells us the problem and knows it are returned as suite substrate 1 because there is no longer in the space of Earth. We multiply this by 50 out of 123. That's give 425 out of 2,542. And this same logic is applied to calculate the probability that two suite of C2 is taken out, but with their respective probabilities, that is 73 out of 124 multiplied by 72 out of 123. That gives 438 out of 1,271. And finally, to calculate the probability at removing one seed of C2, because in the tree diagram, this probability is present both in C1 and C2. And then we took their change of the C1 and multiply of C2 and so this is 73 out of 124 multiplied by 51 out of 123, sum of 51 out of 124 multiplied by 72 out of 123. That's give 2,465 out of 5,084. And this is the percent. To calculate the value to expect value, we did explain an Excel like this. So take the data and like to multiply for the percent, and this is the result, and all that they sum up, and this is the result, 1.174. This means the probability of occurrence has a suite, and this value is taken to calculate the variance and multiplied by the expected value minus the mean, and the result is set to the square of for this. Multiply it the probability, and adding it together gave us the result of 0.4801, and adding all together gave us this result. This in itself doesn't tell us anything, but we needed to get the standard deviation, which is the root of this. The result is 0.6928. This means the values are not taken into account for the value expected, are outliers from the mean. The higher the standard deviation, the greater the dispersion of data, which helps us to establish a baseline for estimating the overall variation of a process. Reflections.
In this project, I was able to remember all the things we see in this topic and how they were applied. And I can reinforce my knowledge about this topic and from this subject.
With this project, I realized in what kind of situations in everyday life we can use probability, and it also helped me to reinforce my knowledge on this topic. I also really like working as a team since we were always supporting each other at all the times, and we resolve our doubts, which is great.
In this project, was able to reinforce my knowledge of probability, especially in the topics of variable distribution, and I was able to practice this in Excel, how to extract expected value and standard deviation.
Thanks to this project, I was able to apply everything that I learned in class. I was also able to develop in a better way my knowledge about mathematics for decision making, and I'm very happy with this project and grateful for the lessons that I learned.
Thanks, teacher.